In this video, we'll be looking at the plotting capabilities of QuantumATK's NanoLab, which includes saving, merging, and reusing plots. The NanoLab plugins allow you to produce a large variety of plots that visualize band structures, projected densities of state, electron-phonon couplings, potentials, and much more. Each of these plots can be edited, saved, and loaded within NanoLab, and the plots can also be merged together in compound plots that visualize complex relationships between configurations, calculations, and analyses. These compound plots can also be reused for other calculations and results. So let's start by looking at some basic plotting tools. Upon opening the analyzer, these are all located below the plot, mostly grouped to the left. The default active tool is the interaction tool, which is the first one on the left. It contains the most functionality, so we'll be going through the different ways it can be used to interact with different plot items. Its basic function is to select individual items in the plot frame, which includes the axis and plot title. Selecting an item may show additional information on the item depending on which analyzer you're using, or reveal additional interactions. For example, annotations such as the measure come with fixed points which can be dragged to set their locations. Specifically for measure items, these points can also be snapped to the data. Right-clicking in the plot frame will bring up a context menu, which contains different options depending on where or what is clicked. Right-clicking the plot background brings up the basic options to auto-scale the plot, which sets the zoom level to fit all plot items, as well as to add additional measures and also arrows and labels. Right-clicking on an item provides the additional options to open the plot editor or to hide the item. For non-data related items, there's also the option to delete them, while for data related items, there's the option to fit the selected data with a function. Similar to the annotations, fitting functions come with their own custom interactions in the form of two draggable lines to set the fitting range. Next is the pan tool, which has two modes of operation. Dragging with the left mouse button allows you to pan around the plot. Dragging with the right mouse button allows you to zoom the plot along individual axes, up and down for the vertical axis and left and right for the horizontal. Moving on to the zoom tool, this allows you to specify a rectangular area to zoom in on. Holding Ctrl or Shift lets you zoom in only the horizontal or vertical directions, respectively. Note that basic zooming in and out is always available using the scroll wheel. You can always reset the view by clicking on the Home button. At the end of the tool group, we find the Edit button, which provides easy access to the same plot editor as mentioned before, and a Save button, which allows you to save the plot either as a .htf5 file, which can be later reopened in NanoLab with the plot viewer, exported as a simple text file, or save it as an image in a variety of standard formats. Finally, at the far right end is the plot merging tool, which acts as a handle representing the plot itself. This handle can be dragged onto other plots to create compound plots and can also be dragged onto its own plot. For example, if you want to analyze the same dataset in different ways and make comparisons. Let's take a look at the plot editor. This window is laid out with all of the plot items in the left panel and editable property fields in the right panel. The entire plot area, which may include many different plots, is laid out in a grid. Each plot is contained within a plot frame, in which you will find a plot title, the X and Y axes, the legend, and all plot items including annotations and fit lines. All items in the list except data sources, marked with a box, are customizable in one way or another. For example, you can set the dimensions of the grid layout and reposition the plot frame within it, as well as change the height and width of each plot frame. You can also flip the axes and change the projection type. For plot items, including the title and axes, there is the option to set the visibility of the item. This is the same setting that is changed when you select to hide an object through the right-click context menu. So if you've hidden something and want it back, just find the item in the plot editor and switch it back to visible. The plot items have many customizable properties that will be familiar to users of common plotting tools. Equivalent items can also be mass selected for group editing. Some good-to-know plot item properties are, for example, the ability to mirror an axis, lock an axis in place while panning or zooming with the mouse wheel, add padding to the autoscale, and use LaTeX formatting in all text fields to write formulas and symbols. Below the right panel of the plot editor, there are some additional item-specific tools. The Zoom tool can be used to zoom in on a particular plot item selected from the list, and fitting functions can also be added to specific plot items from here. The Save button can be used as a data extractor, as it saves the X and Y data for only the selected plot item. Any plots saved as .htf5 files from an analyzer can be reopened using the plot viewer. This allows easy sharing of plotted data between QuantumATK users. The plot viewer comes with all the plotting functions found in the analyzers, so it is possible to make all the changes we've discussed so far, from simple data inspection to adding annotation items and fitting functions. In addition, if the original data is available, there is the option to reopen the original analyzer controls in a separate window. You may have noticed that the plot viewer is also open for all merged plots, so let's take a closer look at how the different drop zones work. When you drag the plot merging tool onto a plot, 5 different zones light up in green. Dropping on the outer 4 zones creates a compound plot with the plots side by side or stacked on top of each other. Dropping on the central zone allows the plots to be merged with linked axes in a few different ways. The linking options will depend on the types of plots that are being combined. Let's look at a different example. We want to plot the projected density of states of a bulk silicon calculation next to its band structure, with the energies linked so that we can compare the density of states for different bands. To do this, select the option to flip and mirror with shared y-axis, which means we will flip the axis of the projected density of states and plot it mirrored next to the band structure. Saving the compound plot is also an easy way to create a plotting template for repeated analysis. You can replace the data of the plots by simply dropping new data on the central zone. If the data is recognized as valid for any of the plots, the data will be replaced. If you now save the new plot separately, you can then reopen the old plot together with the new plot and, for instance, merge them. Thanks for watching. I hope you found this video useful. For more information, please visit the Synopsys and QuantumATK website.